solving multi-step equations. So the first thing we're going to do is just go through a couple of review. So solving multi-step equations. So a little bit what is an equation and how to solve them. So we solve an equation. Solve an equation means to find all values of the variable that makes the equation true. Our ultimate goal is to find out what does the value of the variable equals. Each value that makes an equation true is a solution. And when you have equations with variables, sometimes that variable is going to have one solution, or it could have no solution, or it can have many solutions. Equivalent equations have the same solution. So think of equal, they have the same solution. So equivalent equations are the equations that have the same solution. A multi-step equation is an equation that uses more than one property of equality to solve. And then we work through the order of operations backwards to solve these equations. Normally we follow PEMDAS, which would be parentheses, exponents, multiplication, division, adding and subtracting. But when you solve for a variable, you have to do the opposite. So if I put the letters in the opposite order, it'd be SAD, MEP. So we would do subtraction and addition first. Then you would do multiplication and division last. And then if you have exponents in parentheses, you also incorporate those in there. So in our first couple of statements here, we talked about properties of equality. So what are those properties of equality? First one would be the addition property of equality, which just states whatever I add, if two sides are equal, whatever I add on one side, I must add that same number on the other side for the statements to remain equal to each other. So if I have A plus C equaling B plus C, and A was equal to B before, if I add C to both sides, they still are equal. With subtraction property of equality, it means the same thing. Whatever I subtract on one side, that I subtract the same number on the other side. As long as A equals B, I can subtract any number. As long as I subtract it on both sides, it will still remain equal. And then the multiplication property of equality just means if A equals B, if I multiply both sides by C, they're still going to equal each other. And the division, whatever I divide on one side, I must divide on the other for it to remain equal as long as they were equal from the very beginning. So our first question, use properties of equality to solve each equation, then check your solution. So our first one, 2a minus 6 equaling 4. I'm going to first write that over here to have a little more space. So I have 2a minus 6 equaling 4. So I think right now I'm multiplying and then I'm subtracting, and my answer has to equal 4. But my job is to find out what does a equal. So to do this, I do the opposite of order of operations. So I'm going to do the opposite of subtracting, which would be add 6 to both sides. And we always want to leave the variable to the very end. So don't touch anything with the variable until the last step. So now I have 2a equaling 6 plus 4, which gives us 10. And now I have 2a equals 10. The opposite of multiplying by 2 is divide by 2. So if I divide everything by 2, I end up with a equaling 5. Now to check, if I put 5 in for a, 2 times 5 is 10. Minus 6 does give me 4. 4 does equal 4. So I know my answer is 5. Second one, B. N plus 1 divided by negative 2 equals 15. To solve this one, I don't want to have any fractions or denominators in. So the first thing I want to do is remove the denominator. And to do that, I'm just going to first rewrite my problem. First thing I'm going to do is the opposite of dividing by negative 2. I'm going to multiply by negative 2 on both sides. And now negative 2 divides with the negative 2 here. And I'm left with n plus 1 equaling 15 times negative 2 is negative 30. And now I have one step left. To get n by itself, the opposite of adding 1 is subtracting 1. And when I subtract 1 on both sides, I end up with n equaling a negative 31. Now I need to check my answer to make sure that that makes sense. If I put that in the original problem, and I have negative 31 plus 1, divide that by negative 2, that should give me 15. Negative 31 plus 1 is a negative 30. Negative 30 divided by negative 2 is 15. 15 is equal to 15. Therefore, my answer for n would be negative 31. Another example. Here I have 3m plus 4 equals negative 11. I need to solve for m. So the opposite of adding 4 is subtracting 4. When I subtract 4, I'm left with negative 15 on the right-hand side, and I'm left with 3m on the left-hand side. Now the opposite of multiplying by 3 is dividing by 3. I'm doing that to get m by itself. And whatever I do on one side, I must do on the other. And I'm left with m equaling a negative 5. Now I check my answer, just put negative 5 in for m. 3 times negative 5 is negative 15. Negative 15 plus 4 is negative 11. Question B. I have a fraction here and I do not want a denominator, so I multiply by the denominator on both sides to get rid of any fractions that I have. So 7 divides out with 7 here, and I'm left with 7 times 8, which is 56, equaling x minus 5. To get x by itself, the opposite of subtracting 5 is adding 5. And I'm left with 61 equaling x. If I check my answer, I put 61 in for x. 61 minus 5 would give us 56. 56 divided by 7 does give me 8. More examples of multi-step equations. First one, 11x minus 24 gives us 9. The opposite of subtracting 24 is adding 24. And I'm left with 11x equaling 33. The opposite of multiplying by 11 is divide by 11. So to get x by itself, I divide everything by 11 on both sides, and I'm left with x equaling 3. Letter B, again, I have a fraction here. To get rid of the denominator, I multiply by the denominator on both sides, and I'm left with a plus 7 equals 40. The opposite of adding 7 is subtracting 7. So if I subtract 7, I'm left with a equaling 33. And I want to put 33 back in. 33 plus 7 is 40. 40 divided by 8 is 5. Example 2, write and solve a multi-step equation. So here we're going to write an equation, and then we can solve the equation that we just wrote. So the first question, the student council raised 2/5 of the money they need to cover the cost of the school dance with a bake sale. Just a reminder, when it says of the money, a fraction of or part of, that tells us we are going to be multiplying here. They raised an additional $150 selling raffle tickets. Here's a keyword additional, which means we are going to be adding 150 somewhere in our equation. If the student council has raised $630, so this is their total, what is the cost of the dance? Write an equation for the problem and then solve the equation. So the student council raised 2/5 of what? 2/5 of the money they needed to raise to cover the cost. We don't know the cost, so I'm going to put a C for cost. So 2/5 of the cost they raised, plus the additional $150 they raised, gives us the total raised of $630. Now that we have our equation, now we're going to use the order of operations in reverse order to solve. So I need to get 2/5 C by itself. The opposite of adding 150 is subtract 150. When I do that, I'm left with 2/5 C equaling 630 minus 150. This will give us 480. Now, the opposite of multiplying by 2/5 is multiplied by the reciprocal. So if I multiply by the reciprocal, that would be 5/2, which will give us 1C here, which is what I want, C by itself. Whatever I do on one side, I need to do on the other, so I need to multiply this by 5/2. So you can either take 480 times 5 and then divide by 2, or you could divide that 480 in half and then multiply by 5. Either way, you would end up with C equaling $1,200. So our total cost of the dance would be $1,200. Moving on to the next question. It says this morning the store sold 2/3 of its basketballs, but 8 were returned. Now the store has 38 basketballs. How many were originally? Write an equation for the problem and then solve the equation. Now for this one, it is very important that you read carefully what the numbers represent in the problem. So here it says they sold 2/3 of the basketball, which means they do not have 2/3. But this 8 were returned, which means they have 8 basketballs that they have. And now they have 38 basketballs in total left over. I want this fraction here, this 2/3, to represent how many basketballs that they have left. So if they sold 2/3, that means they kept 1/3 of the basketballs. So B for basketballs. They gained 8 more because 8 of them were returned. And they have a total of 38. So there I have an equation. And if I look at my choices here, I know that A and B does not work. C and D both have 1/3, but one of them says I'm subtracting 8. They didn't lose 8 more, they gained 8 more after they sold a few. So the correct answer would be C. And then how did they get that 90? All they did was solve for B. And to solve for B, they subtracted 8 on both sides, and you get 1/3 B equaling 30. The opposite of dividing by 3 is multiplying by 3. And that's how we get the basketballs at a total of 90. Next example, snowboards. Hiroshi is buying a snowboard that is on sale for 3/4 of the retail price. So 3/4 of the original price. After he uses a $50 gift card, the total cost before taxes is $190. Write an equation for the original price of the snowboard and then solve the equation. So what we're going to do is look at everything with the cost. So it's on sale for 3/4 of, again, remember multiplication of the total price. So I'm going to use P for price. And then they're using a $50 gift card. So 3/4 of the cost plus the $50 that they're using. Says after he uses the gift card, the total cost before taxes is $190. Now let me go back to our original question. When it says after he uses it, the total cost is 190. So that means I have to take away $50 because I used $50 on it, and then the final cost is 190. So keep that in mind. If it said before he uses $50, then I would add the $50. But because it says after, I need to subtract that. Now I just solve for P by adding 50 to both sides. And I'm left with 240 equaling 3/4 P. Now the opposite of multiplying by 3/4 is multiplying by 4/3. And I take my calculator, I can do 240 times 4/3, so I can do times 4 and divide by 3. I'm left with 320. So the price of the snowboard would be $320. Example 3. Some equations have coefficients that are represented by letters. To solve these equations, apply the process of solving equations to isolate the variable. So the common struggle that students have is when there's more than one variable and not enough numbers in there, they get confused by the variable. When you have more than one variable and they're telling you to solve for a specific one, just worry about getting that one variable by itself, and everything else will take care of itself. Okay, so here it says solve ax plus 7 equaling 5, and we're solving for x. That means I need to get everything away from the x. So if I rewrite this, I have ax plus 7 equaling 5. I need to get everything away from the x. So I have ax together. I cannot touch that until I get rid of this 7. So the opposite of adding 7 is subtracting 7. And I'm left with ax equaling a -2. Now I still need to get x by itself. And right now they're telling me I need to multiply that by a. I don't know what a is. We don't need to know what a is. We just need to get x by itself. So the opposite of multiplying by a is divide by a. And whatever I do on one side, I need to do on the other. So ax divided by a is just 1x. And that's going to give us a -2 divided by a. Now, a can be any number as long as it's not 0. That's why they say assume that a does not equal 0 because we cannot divide by 0. Now, this is our solution. We just solved for x. We got what x is by itself. That is your ultimate goal. You do not need to solve a specific number for x or a specific number for a. Next one, solve 2 minus ax equaling -8 for x. So we need to identify which variable we're solving for, which is x. So I'm going to write that on the side here, 2 minus ax equaling -8. I need to get the ax by itself, so I don't touch that until the last step. So right now, this is a +2. The opposite of adding a +2 is subtracting 2 on both sides. So I just think of whatever sign's in front of the number, I do the opposite. Now I'm left with ax, negative ax, equaling a -10. Now to get x by itself, I need to divide by a -a. Whatever I do on one side, I do on the other, and I'm left with x equaling -10 divided by -a is a +10 over a. My answer would be x equaling 10 divided by a, which would give us choice D. And the last one for example 3. So solve 1 over ax, 1 over a times x minus 8 equals 9. Solve for x. So I'm going to rewrite this a little bit differently. I'm going to put the x on top and a on bottom because 1 times x is x divided by a is x over a minus 8 equaling 9. Now I need to get this x by itself, so I'm going to add 8 first to both sides, and I'm left with x divided by a equaling +1. Now the opposite of dividing by a is multiply by a. The a's divide out, and I'm left with x equaling 1 times a, which is a. So whatever x is, my a is also going to be. So that is our lesson on solving multi-step equations.